So now we're going to work on solving quadratic equations, completing the square, but when the leading coefficient, or a, is not a perfect square. There have been other cases which I have reviewed where the leading coefficient is 1, right? And so explaining what we're supposed to use with that, and when the leading coefficient is a perfect square. Well, we're going to go over now, or I'm going to go over with you, what happens if the leading coefficient is not 1 and it's not a perfect square? Well, assuming that you've tried every other way to do this, what you can do is look at it and decide, well, I'm going to make it a perfect square. And so let's take a look. This is my leading coefficient, right? 3. And, it's not a perfect square. So what number would I have to multiply 3 by to make it become a perfect square? Well, it's very simple. We're going to have to multiply it by 3. So we're going to do that to both sides. We're going to multiply by 3 here. Okay, and we're going to multiply here by 3 and this by 3. What I do to one side, I have to do the other. Okay, so when I multiply there by 3, I get 9x squared plus 9x equals 54. Okay, now we're going to use our formula to figure out what this missing piece is. Now this is a perfect square, so we're going to have to use this one here, which is for perfect squares. If it was a 1, we would use b over 2 parentheses squared. Okay, so anyway, we're going to take this, and what's my b? Well, my b is 9, so that's going to be 9 squared. 4 times, what's my a? 9. And I'm going to get 9 times 9, 4 times 9. I'm going to get, the 9's cancel, and I'm going to get 9 over 4, which is a fraction. Perfectly fine. Okay, so here's what we're going to do. We are going to have to create a perfect square, and we are going to have to add 9 over 4 plus 9 over 4. Okay? Now, what's going to happen? Here's a perfect square, 3x. This is positive plus 3 over 2. 3x plus 3 over 2. I had to make the 9 over 4 the perfect square, right? Okay. Now, this is equal to 54 plus 9 over 4. We can make that into a decimal if we really want to, but first let's figure this out here. Okay, just to double check. Okay, so when we look at this, when we multiply, we get 3x times 3x, 9x squared, 3 over 2 times 3 over 2, that'll give me 9 to the 4th. And then to get the middle term, you actually have to look at, just to review it, and I'm going to write this on the bottom. Let's see. Just as a reminder, right? And then I'm gonna put this here, like as a little reminder. So these two would be 3 over 2 times 3x over 1. And this one here, these always give us the middle terms. 3x times 3 over 2. Okay? Well, we get 9x over 2 plus 9x over 2, which is 18x over 2, which is 9x, right? Which is exactly what we want. So that's cool. Now, that's just a little side note. So we'll leave this kind of separate from the rest, right? Let me put a little circle around here so you know that this was just explaining what was going on. All right, so we know it works. So I'm going to come down here, and I'm going to write 3x plus 3 over 2, 3x plus 3 over 2, and that was actually adding 9 over 4, so what I do to one side, I have to do the same to the other, equals 54 plus 9 over 4. Okay, that is 3x plus 3 over 2 squared is 54 plus, what's 9 divided by 4? let's see, because we've got a lot of fractions going on here. So 9 divided by 4 is 2.25. 54 plus 2.25, which is 56.25. 3x plus 3 over 2 squared. Now we're going to take the square root of both sides. Okay, that gives us 3x plus 3 over 2 equals plus or minus the square root of 56.25. Okay, and that gives us, we're going to call this 3x plus 1.5, and I'm going to convert this plus or minus to fractions. If you put it into your calculator, 56.25, the square root is 7.5. That makes it a little easier, right? Okay, so we're going to use, I'm going to put the positive over here, and I'm going to do a different color, okay? So that maybe it's a little easier to see. Here's the positive. Here would be the positive. 3x plus 1.5 equals positive 7.5. Well, I subtract 1.5 from both sides. And hey, this is going to come out pretty nice. 6.0. 3x equals 6.0 divided by 3 on both sides. X equals 2. Well, that's not so bad. We had a little bit of a mess. When we start to get a lot of fractions, you can just go ahead and put them into decimals. I really prefer the fractions, but we have a fraction here, a fraction there, and so it's probably easier to just put that into decimals. So let's see the next one. Well, if we have the negative side of it, I'm going to do this over here. We would get 3x plus 1.5 equals negative 7.5. So when I subtract negative 1.5, I get 3x equals, well, negative 9, which when I divide by 3, wow, that's pretty easy. See how ugly that thing looks? A lot of decimals, fractions, and everything. And it just turns out it has two solutions. X is equal to 2 or x is equal to negative 3. And that just goes to show you sometimes it looks like, oh man, I did something wrong because this is looking too complicated, but it works out very nicely at the end. So that's one thing to do. You look at that. If it isn't a perfect square, well, you make it into a perfect square. And by the way, you could have also done what, 3 times, well, no, it would be 3 times 3 because 3 times 3 is 9. So that's one example. Now, hopefully this one won't be as bad, but this is a case when you're going to get a larger number. But what happens when you're dealing with a fraction? Well, my highest recommendation is if you're looking at this and you're saying, okay, this is not a perfect square. So you've got a choice. You can multiply, you can make this a perfect square, or if it's a fraction, why don't we just go ahead and eliminate the fraction since this is a 1 on the top and make it a 1? And use the formula that we use, b over 2 squared, to find what we should put here and add it to both sides or subtract it to both sides depending on the case. In this case, it's going to be adding. We'll make it a 1. And that's a lot easier. What number do I multiply 1/2, right? That will 1/2 times what number, right? Times what number will give me 1. And that's simple. It's the reciprocal times 2 over 1. That, when I multiply 1/2 by 2 over 1, I'm going to get 1. So what's another way to write 2 over 1? 2. We're going to write, we are going to multiply this entire thing by 2. The whole thing, because what I do to 1, I got to do to everything. So 2 times 1/2 is x squared. We know that already. 1/2 times 2 over 1 is 1. If you want, we'll put a 1 here. 2 times 3, 6x. I have nothing else. And then 2 times 14. Oh, I'm sorry. I did that wrong, didn't I? 1/2. This should be a 3. And this is going to be a 14. Now we're going to use the distributive property and we're going to change it. So we're going to multiply this. Okay? This would give me 1x squared. This would give me 6x. And this would give me 28. All right. Now, we are going to figure out what I have to add here to make, and here, to make this a perfect square. Now, this is a 1, so we're going to use b over 2 in parentheses squared. What is my b term? The second. This is my a, that's my b. So this would be b over 2 squared. Okay, so 6 over 2 squared. What's 6 divided by 2? 3. So that's 3 squared, which is equal to 9. Okay, so that means I have to add 9 to both sides. And what that does for me is I get x squared plus 6x plus 9. Okay, keep in mind that here it's 3, right? And that's 28 plus 9, which is 37. All right. Now this one kind of looks easier, but it's going to come out a little ugly, I think, but not too bad. All right. So we're going to have to find the perfect square of 37 and the perfect square here. This one, let's go ahead and figure it out. X squared is x times x, and 9, 3 times 3, there's my number, and it's positive, plus 3, plus 3. 3 times 3 is 9, and 3 plus 3 is 6. That's why that works, is 37. X plus 3 squared equals 37. So to figure out and to break apart this square, I need to take the square root, right? And that gives me x plus 3. Now, because I'm taking the square root, I don't know if this is squared, it could be positive or negative. Okay? All right, then we subtract. Let's see, let's first, I like to divvy it up first. Let's do the positive side. So, if my answer will be positive, it's going to be x plus 3 equals positive square root of 37. So, I'm going to subtract by 3, both sides. Can't subtract by 3 with a square root of something. Because I can make this if I put it into my calculator and got a decimal, then I could combine them. But I'm just going to leave it as a square root, x. And so that if I put it behind it, I have a good chance of making a mistake and making it one square root or just getting confused. So I usually put this in front plus square root of 37. That's one answer. Now, what's my second answer? I'll do this one in green. I haven't used green in a while. Okay, so I have x plus 3 equals negative square root of 37. I'm going to subtract 3 from both sides. X equals, right, negative 3. I'm going to put just the plain number in front minus the square root of 37. Now look at your two answers. I didn't change anything with the square root of 37. All that's different, x and x are the same. Negative 3 is the same. What's different is plus 37 and minus 37. And those are your two answers. So that's basically how you figure this out. Look for making it either a perfect square or just making it, 1 as as your leading coefficient. And you can work it that way. You either can work it if there's a number in front or just a 1, you can work it either way. And that's what you want it to get to. What you can't do is if it's not a perfect square, like if it's another number like 3 or 5 or 10, whatever, or 1/4 or 1/2, well, actually 1/4 is a perfect square, but 1/3 or 1/2, then you do have to change it to either 1 being the leading coefficient or a perfect square. And that's it. So good luck, doing your word problems. And I hope this helps. Thanks.